మీరు కొంచెం అటు జరుగుతారా సార్? Mic off and okay, nice. So hi guys, for a change we are now going to try a new thing here. Class same అలానే ఉంటుంది కానీ iPad లో కాకుండా I'm going to use this board this time. So yes, we will try to understand a new concept today. Okay, we are starting to learn a new concept which is exception handling. Okay, so up till now we have covered so many topics, but this is one of the important class that you should never miss. Okay, so we will start understanding this topic from scratch. What exactly is exception? Okay, so first to handle an exception, you have to understand what exactly an exception is, right? So we will start understanding that first. Exception is an unexpected event. We can consider that as an unexpected event. Okay. So, what exactly is an event? Whenever we execute any program, if we encounter an unexpected problem inside a specific program, then we can consider that as an exception. Okay. So, there are types of exceptions that are available here, but for one of them, we have to first justify and differentiate between two things called as an error and an exception. Okay. Now, we have seen errors all these days in our execution point of view, right? We get compile time errors, we get runtime errors. We have seen those errors. Like the example can be whenever you are given a specific input, like let's say you are asking for a integer input and you have given, let's say, Boolean value for that input. And that time you will get a specific exception named as input mismatch exception. That type of things, we consider them as actually errors, right? So actually, they are not errors. They can considered as exceptions here. So first, we will have to understand when do we actually consider them as errors. Okay, so let me differentiate both of them. Okay, error is a serious problem which cannot be rectified. Okay, so exception, on the other hand, is something that can be rectified. Okay. On the other hand, errors can happen due to external reasons. But exceptions always happen inside the application flow. Okay. So this can be another reason that we can differentiate here, right? So as in terms of examples, if we want to talk about this, you can consider recursive calls of a method as a error, and input mismatch can be an exception here. Okay, what exactly do I mean with recursive calls? Let's say I have a method, so void m1 of int a. Let's say this is a method that I have. And irrespective of this, if I call m1 of 10 inside this method, okay? So what exactly is going to happen here? Whenever we call this method from our main method, something happens, right? We will pass a value from main method. Let's say we called m1 of 100, okay? Now, this value is going to be stored here and this method is being invoked, right? Now, after invocation of this method, it is going to invoke the same method again, right? And what exactly happens is there is something called as a methods call stack, okay? method called stack. What does this exactly do? Whenever any method is invoked, the memory regarding that specific method is going to be stored inside this specific stack. Okay, so the first method that is going to be invoked in this entire scenario is a main method. Of course, that is the first method that will be executed whenever you run any program, right? So in this main method, we are going to call m1 method. So this is the next method that we are going to create here, right? So that will get memory allocated in our stack. And what are we doing in our m1 method? We are calling m1 method again. So what exactly happens is the memory for that new method that has been called will be created there, right? Again, what is going to happen, sir? It is going to call m1 method again, and sometime or the other, the stack is going to be filled completely. Okay, but there is one reason behind this. Okay, so what exactly happens is this method called stack is actually growable in nature. Okay, it can grow its size multiple times. Okay, this will happen, this will keep happening multiple times. It will again try to grow its size. Okay, so it will keep happening multiple times, but until when will this be growing its size is until the memory in our computer gets drained out. Okay, so meaning we will generally have 8 GB of RAM, right? So this the exception that might occur here is regarding of this memory space that we have available here. So these multiple method call stacks will not be in number of tens or hundreds, but in thousands of calls will be happening here because of the recursive calls that we have made here. And eventually this 8 GB will be drained out, right? So whenever we do not have any available memory left for our Java application to work properly, then there will be an error that will happen here, which is stack overflow error. Okay, so this is an error that will happen in this regarding scenario. Okay, but why do I call it as an error? Again, this error has come up because of an external reason. External factor is affecting this problem. Consider having unlimited amount of RAM in your laptop. Unlimited amount of RAM in your laptop. Does this problem ever come up? Because as we know, stack method called stack can be growable in nature. It can grow into unlimited size if you have unlimited amount of memory available, but that's not the case here. That's not the real world case, right? You will have limited amount of memory only, right? So whenever the limit reaches, then there is no more space for the stack to grow its size, and then the stack overflow error will arise, and that has caused because of the external reason, which is memory, right? So that can be an example of an error. Errors always happen because of the external reasons only. It will never happen because of internal program problems. Okay, another type of errors can be the compile time errors. I'm sorry. So the maybe the syntactical problem. Okay, syntactical problems can be another reason here. This will raise your compile time errors. Okay, suppose let's say you used something like system.out.println. Okay, now this is a mistake that you have made in your code, right? Hard coded mistakes are considered as errors again. Okay, so that can be another reason here. But what about an exception? When does an exception get raised? Okay, so exceptions are unexpected events that happen in a program flow of execution. I will take an example for that also. Okay, let's consider we have a program flow of execution of maybe a variable where we are assigning 10 as a value, and let's have another variable where we have, let's say, 2 as a value. Okay, now if I am trying to do a plus b, what would be the output of this? If I'm right, this the output of this program will be 12, right? Perfect. Wait, no problem, not at all. It will properly execute this program and nothing is going to change here. But what exactly the problem will be is if I replace this value with 0 and run it again, now this time the value will be 10. The output value will be 10. There is no problem. But if I change this arithmetic operation to division, okay, and what are we trying to do, sir? We are trying to divide something with 0, right? Can we divide anything with 0? It is simply impossible. So it is specifically a undefined value, right? It is an undefined value because let's try to solve that generally with 0. 0 times how much is 10? Even if we write infinity here, let's consider infinity as a number and use that number here. 0 times infinity is again 0. It's not 10, right? So it will never be ending here. So that is why we call this process as an undefined operation, right? But still, it is undefined for us. Does the computer can work on it? Again, computer also cannot get to a conclusion here. Instead, it is going to get stuck by performing this specific operation. It is not going to complete that operation anytime sooner, right? So what it will do is, what our JVM intelligently does is, JVM will recognize that there is a problem here and it will specifically throw a exception called as arithmetic exception. Okay, so what exactly is an arithmetic exception? We are performing an arithmetic operation here, and that arithmetic operation is not resulting in a specific value, and hence we get an exception called as arithmetic exception. Okay, so and as I said, these exceptions can be rectified, and it actually happen inside application flow, or you can also call this as program flow of execution. Okay, it can also happen inside the program flow of execution or application flow. Both are one and the same. Okay, so it is not hard coded mistakes, but it can happen because of the invalid inputs provided by a user. Okay, suppose let's say these two are not a static values, but values that are provided by a user. That's okay. Let's take scanner inputs here and then let's consider them as values that are provided by user. Okay, so what exactly happens is, if the user provides 10 and 0, okay, if the user only provides 10 and 0, meaning in the denominator, if he provides any 0 value, meaning in the b variable, if he provides 0 value, then there is going to be an error that might happen here, the exception that might happen here. If there are another chances of user also providing 10, what is the probability of getting of user inputting 0 in the denominator here? Very, very less, right? So there might be chances of not getting an exception, and there might be a chances of getting an exception also. Okay, so in this scenario, it might not always result in an exception, right? So that those kind of problems are actually considered as exceptions. But in this scenario, comparing with error again, but in this scenario, irrespective of whatever is going to happen, if you run this application, it is going to end up in stack overflow error. Okay, so there is no alternative things for this. This is going to be always resulting in errors only. Okay, so specifically talking about this concept, errors are not meant to be handled. Okay, errors are not meant, I'm sorry, to be handled. Okay, why do I say this? Let's talk about the reason behind the statement. Specifically, the error that we have seen just now, the stack overflow error, has not occurred due to the reasons inside the applications. It has occurred due to an external factor, which is the memory, right? So there is no way that you can actually handle or make an alternative of this memory that you already have there, right? So out of memory error is an error that cannot be handled. Stack overflow is an error that cannot be handled. Okay, so errors in general will not be handled by any user. They cannot be handled specifically. Okay. So on the other hand, exceptions can be handled. Okay. And why do I say this? In this example that we have seen, this is a exception, or this is a problem that we got because of the invalid input provided by the user in the denominator, right? Whenever user does this, we can talk to the user, we can interact with the user stating that you should not be providing this type of values here, instead provide any other value. Meaning, all the handling that we can do here is all the handling that we can do here is either providing user friendly messages or providing alternative code or simply information about the error or exception. Okay, information about exception. You can do these three things whenever we call as handling. Okay, so whenever an exception is raised, meaning whenever an uncertainty in the program occurs, you can either handle it by providing an user friendly message stating that it should not be done in that specific way, or you can provide an alternative code. If that code is not working, you can utilize this code like that, you can do something like that, and or you can provide information about the exception that you are actually raising. Okay, so these are the three things that are actually considered as handling, okay, which we will talk about it later on. But as of now, this is a brief introduction about what exactly error is and what exactly an exception is. Okay, so we have to talk about this in perspective of exceptions always, because in Java errors are something that cannot be handled and only we can handle exceptions, and that is the reason why we have a topic named as exception handling. Okay, so in this concept we have understood what exactly the error is and what exactly the exception is, right? So in Java, there is a specific hierarchy, a specific structure where we are going to see how these exceptions are actually created internally. Okay, we can talk about, there are two types of exceptions generally, which are predefined exceptions and user defined exceptions. Now, what exactly are predefined exceptions? What exactly are user-defined exceptions? Now, if I you like whenever we have Java installed inside our laptop, we have installed all the API regarding that specific software, right? We call that as generic API. We already have that inside our laptop. In that specific API, we have all the predefined exceptions that are created by Sun Microsystems for us to make use of them. Okay, so they are already there here. The example can be the Stack Overflow error, the arithmetic exception, the input mismatch exception. These are already there, which are available, right? And on the other hand, we have user defined exceptions, meaning we can create our own exceptions. Example can be invalid login credentials exception, which is a user perspectives, which is not a global exception that might occur. It can be a problem in a specific application only. So these type of exceptions can be created by the developer for a specific project only. Okay, invalid login exceptions, invalid pin exception, all right, or invalid password exception. So all these can be an exceptions that you can create as your user defined exception in Java. Okay, but nevertheless, we already have predefined exceptions which are already created for us in Java software, the generic API, right? So we are going to understand that structure first. Okay, if we understand how these exceptions are created by developers in Java, we can create our own exceptions in a easier manner. Okay, so we will talk about this user defined exceptions later on. As of now, we will only focus on predefined exceptions part. Okay, so this predefined exception part is actually considered as two there are two sub classifications for this. Okay, this can be considered as a asynchronous exceptions and synchronous exceptions. Okay, asynchronous exceptions and synchronous exceptions are the classifications for the predefined exceptions that we have. Okay, now what exactly is an asynchronous exception? Again, this will take us back to something that we have already learned in this session. Asynchronous exceptions are the exceptions that occur due to an external factor. Can you guess what it is? Of course, the error. Asynchronous exceptions can be considered as errors. Okay, so errors also can be called as asynchronous exceptions. Okay, so the exceptions which are raised because of an external factor such as memory, such as virtual machine errors, such as stack overflow error, it can be any reason. All these are considered as errors. Okay, and then we have something called as synchronous exceptions, the exceptions that occur in the program flow of exception, sorry, in the program flow of execution. Okay, so synchronous exceptions occur in the program flow of execution, and asynchronous exceptions occur in with respect to an external factor. That is the difference that we have. Again, synchronous exceptions are classified into two types. The first type of exception, synchronous exceptions, are checked exceptions. The other type of exceptions are unchecked exceptions. Again, this might feel like overwhelming already, but I want you to focus more here. We will understand all these things. We'll connect all the dots later on. Okay, as of now, we will talk what exactly is checked exception, what exactly is unchecked exception. Now, checked exception is an exception which needs user to definitely handle them. Okay, mandatorily to be handled. The program will not continue, the program will not get compiled if you have a checked exception in your program. Okay, so these exceptions are the exceptions which will occur during the compile time. Okay, these exceptions are the exceptions that will occur during the compile time. Okay, on the other hand, unchecked exceptions are not necessarily to be handled. You will not be required to handle them. If you want to execute a program, you still can execute a program. But if you handle these exceptions, you will not get any error, or you will not get any interruption of program. But if you do not handle these exceptions, the program execution will be interrupted by the exception that is going to come. Okay, in this scenario, you have to definitely handle the exception if you want to execute your program. The difference is you can execute the program. You can execute the program even if you have an unchecked exception in your program specifically. Okay, if you handle it, you will not see any interruptions in the code. If you do not handle it, you will see the interruptions in the code. On the other hand, checked exceptions definitely wants you to handle them. Without handling them, you cannot run the application. That is a simple difference. This will occur during runtime. Okay, these exceptions generally occur during runtime because, like as I said, arithmetic exception is a checked exception, the unchecked exception that we have, because there is a scenario of only one in maybe million chances where you will only entering zero as a denominator is going to cause an exception for you, right? So that is a thing that might happen based on the user input in the runtime. So that can be considered as a runtime exception. On the other hand, there are exceptions that are going to be raised during compile time, which can be considered as checked exceptions. We'll talk about that also. Okay, but these are the classifications that we generally have. Okay, so predefined and user defined exceptions is the first classification that we are going to do, and in that when we are going to learn about predefined exceptions, there are two classifications. Asynchronous and synchronous. Asynchronous exceptions generally means they are errors, because the definition itself says that asynchronous exceptions are the exceptions which will occur because of an external factor, not because of the internal programs. Okay. So synchronous exception, on the other hand, is actually occurring due to the program flow of execution, in mismatch in the program flow of execution. Okay. So these can be actually considered as exceptions, and the asynchronous things are errors. Okay. Now there are checked exceptions and unchecked exceptions as a part of synchronous exceptions. Checked exceptions need to be handled mandatorily, and unchecked exceptions can be left out like that. These are runtime exceptions, these are compile time exceptions. Okay. But we have to understand the structure behind this entire, like the architecture, the hierarchy of exceptions, and how they are implemented in Java. Okay. So to start with that, the first and the foremost class that we are going to have here is java.lang.object class. Okay. So this is the first and the foremost class that is in the hierarchy of the exception syntax, everything. Okay. Now we'll take it as a main superclass, because of course Java object is a superclass for all classes. We have to consider that everywhere. Followed by that, we have, excuse me. So we have java.lang.throwable. Okay. Now, this is an important class in the entire exception hierarchy. What exactly does this do is, it will specifically tell whenever the exception is occurring. It will help the user understand what is the exception, why is it occurring, where is it occurring, and all these details are actually provided by this specific class. Okay. Throwable class is an important class, which is a super class for all the specific classes that I'm going to write here. Okay. So this class is responsible for providing all the necessary information about any exception that is going to be raised in future. Okay. So what are the exceptions that are going to be raised here are going to be coming under this specific class. Okay. So as I said, there are two specific things. There are errors and there are exceptions. Those both are the subclasses of the throwable class itself. Okay. So we will have something called as java.lang.error, which is a class, subclass of throwable class. Okay. So this class can be considered as asynchronous exceptions. Okay. Whereas on the other hand, you have something called as java.lang.exception. Yes, exception is a class, error is a class, which are helping you to classify all the different types of errors and exceptions. Like let's say there is arithmetic exception, there is something called as array index out of bounds exception, there is something called as string index out of bounds exception. These are all the subclasses of exception class. Again, understand the inheritance that we are going to see here is only to help in reusability of code, not to create them multiple times. Instead, creating them at a specific class and letting all the subclasses use those specific properties. That is the reason why we have all the classification as error and exception here at super level. Okay. And this exception class can be considered as synchronous exceptions. Okay. All synchronous exceptions will come under the exception class. Okay. And all asynchronous exceptions will come under the error class. Okay. So do we have any subclassification under the error class? No, but we have a inheritance which is going to be inherited by few classes that we already know. Okay. So stack overflow error is a class that we have. Yes, again, all the exceptions that you see in your compiler whenever they get raised are actually classes. Okay. Stack Overflow error is a class which is a subclass of error class. There is a error of out of memory error. This is also a subclass of error class. There is something called as virtual memory, sorry, virtual machine failure error, which is also a subclass of whom, sir? Error class. Okay. So error has multiple subclasses. All these are in form of hierarchical inheritance. Okay. Hierarchical inheritance, which will specify all these things. Okay. Meaning all these have a superclass of error. These are not connected one by one like that. Okay. All of them are connected to directly error class. Okay. So coming to exception class, meaning the synchronous exceptions, we have already discussed that there are two types of synchronous exceptions, right? So they are checked exceptions and unchecked exceptions. I'm not going to classify them directly here. I'm going to write about the classes and the hierarchy of how we generally have these exceptions. So we will classify them later on. Okay. So there is a specific hierarchical inheritance that is also there here. Okay. So the first class that we can talk about the subclass of exception class is class not found exception. Now, class not found exception is an exception which will be raised whenever there is no class definition that is found from our jar files. Okay. So to understand this specific meaning of what exactly does this do, we have to understand the advanced Java concepts like JDBC and servlets, where we are going to import the external libraries into our application and use them as Java classes, right? So we have to wait till then where we have to understand about class not found exception. So we will not discuss much about that, but understand that this is a exception subclass. Okay. And then there is something called as file not found exception. I can talk about this specific exception because it will be easy for us to understand rather than class not found exception. Okay. So whenever we want to transfer any data that we create in our Java application to an external file like this, let's use a new page. Whenever we have a Java application and you created some data here and you want to transfer this data into an external file, okay, let's say .txt application, you need to create a stream here. Okay, it should be a file output stream, or you can use any output stream object specifically. Okay, so we haven't learned about all these things yet, but what we'll call this is a stream. Okay, so we have to actually create a stream of connection between our Java application and the external file that we have. And whenever you are trying to transfer the data to that specific location, it will be using the stream to do that operation. But while creating the stream, you have to provide the destination address. Okay, which is specifically the path of this specific file. Meaning if this file is located in D and let's say files, and let's say you have a file like file.txt. Let's say this is the address. This is the file where I want the data to be stored. This entire thing is considered as the path of that specific file. And we have to use that path in order to connect the stream to that external file, right? And if you have this file available there, then there is no problem here. Okay. But if you do not have this file available in that path, then you will get a specific exception called as file not found exception. Okay. So this is again an exception that will be raised and is considered as a checked exception. Okay. We'll talk about that again. Let's see the hierarchy here. Okay. There are IO exceptions. There is something called as SQL exception. There is something called as interrupted exception. And all these exceptions are the exceptions that we are going to interact or deal with in future. Meaning, in the future concepts of learning, we will talk about all these things. And all these classes that I have written here are considered as checked exceptions. Okay. So one direct thing that you can understand about a checked exception is checked exceptions are the direct subclasses of exception class. Okay. So they are the direct subclass of exception class. And then there is another important class which is runtime exception. Okay. So there is this class called as runtime exception, which is acting as a superclass for all the classes that I'm going to write down below here. But then this will define all the unchecked exceptions. Okay. So let me write all those things again. I'm sorry. So there are few classes like arithmetic exception. We have something called as number format exception. We have something called as null pointer exception. We have array index out of bounds exception. We have input mismatch exception. We have a string index out of bounds exception. All right. These are some of the exceptions that we have generally. Okay. I cannot directly write all the exception classes that we have in Java because there are so many exception classes that are available. I have mentioned few of the exceptions that are most commonly used in Java and which are actually easy to learn. Okay. So all these classes that I've written here are considered as unchecked exceptions. Okay. Meaning JVM will not worry if this exception is there or not. Meaning these are the exceptions that can happen 1 in a million chances there. Okay. But if we talk about checked exception, they have to definitely be handled. If not, they are not going to be executed by the compiler. Okay. So keeping one thing in mind properly, can you differentiate how do we define checked exceptions and how do we define unchecked exceptions? There is one specific important point here. Okay. All the classes which are the direct subclasses of exception class, meaning all these classes are checked exception classes. Okay. And whenever you have this runtime exception in between and you see all the classes as subclasses of runtime exception, right? So this runtime exception subclasses are all considered as unchecked exceptions. Okay. So you will also see this if you have an habit of reading the Java documentations and reading about the new classes that are there in Java. If you see if any class is extending or inheriting the properties from runtime exception class, then you can consider that as an unchecked exception class. Okay. If you see any class which is directly inheriting the exception class, you can consider that class as a checked exception class. Okay. Why do we have to talk about that? Why do we have to keep a mind eye on that specific description is you have to definitely handle checked exceptions in order to execute your program. If you are not going to handle any check, if you do not want to handle any exceptions yet you want to run the application to see what exceptions that are arising in that application, then you have to make sure all those are unchecked exceptions, because if you have any checked exception in your program, it will not let you execute that program. That is a simple important detail that you have to keep in mind. Okay. So this is the entire hierarchy that we have to remember. Okay. not the classes, but the structure here. Okay, so what exactly happens is whenever any of these exceptions arise, because maybe you created a code in such a way that any of these exceptions arise in that, what exactly happens is a respective class object is created, and that is taken to the throwable class. Okay, and we will talk about that specifically in detail. We will talk about this exception, what exactly happens, how do we actually see the statement. We might have seen something like this already. Like, let me write that entirely here. You might have seen something like this, guys. Okay, if whenever any exception arises, something like this always pops up in your screen, starting with exception in thread, the name of the thread. Okay, so whenever you get this type of syntax, you will understand that there is a problem that you have in your program, right? So do we have to understand this entire thing? Yes, it is very important to understand this, because this has so many details which will help you to rectify that exception properly. Okay, so what are we looking at? What do we have to understand from this? Let's see this same thing with an example program. Okay, so let me create a scenario. Okay, I will explain that scenario first. Let's say there is an m1 method, okay, which is doing division of two numbers which are which it gets as parameter. Okay, and then there is, let's consider there is m2 method which simply calls m1 method. Okay, and let's say there is m3 method which simply again calls m2 method. Okay, and let's call let's say main method calls m3 method. Okay, from main we'll call m3, from m3 we'll call m2, from m2 we'll call m1, and m1 inside m1 we will actually perform an operation as division operation. Okay, so let's create this syntax. Okay, or the programmatic approach of that. So for that, I will definitely need a class. Let's say class A. Inside this class, I'm going to create a method void m1 of int a comma int b. As I said, m1 has two parameters, and I am going to divide those parameters. Okay, like this. And let's call m1 method from m2 method. Okay, so I do not have any parameters or return type for this method. I'll simply call m1 of parameters, let's say 10 and 2. Okay, sorry, I should not be doing that. 10 comma 2. Okay, and let's say we call another method m3 of, which is simply calling m2 of. Okay, now from main method, let's call public static void main. I'm writing this in short form. This is public static void main. And let's consider we are calling m3 method. As m3 is a non-static method, we are calling under static area. We need an object to call that. So let me create an object of my class. Okay, a obj equals to new a of, and then obj dot m3 of is my code. Okay, so by doing this entire scenario, what have I done here is I have created a code which executes in a certain manner. Okay, so what does it exactly do? We will understand that step by step. Okay, whenever you compile this code, okay, whenever you compile this code, what do we generally do, sir? We'll save that file with the class name and java c a.java is something that we do, and java a to run the bytecode, right? And when we do this, it will internally invoke a dot main automatically. And when a dot main is invoked, it will directly come to your main method, right? In the main method, you have an object creation as your first statement, meaning that will be executed first. And whenever an object is created, whenever that syntax is executed, an object is created. In this object, we have m1 method, m2 method, m3 method, because all of them are non-static properties, right? So we have all these properties that are declared properly. Nice. Now what are you doing, sir? You're calling m3 method from object, right? So objects m3 method is being invoked. Now let us zoom in this a little bit in, and let's understand what exactly is happening. Now from here, the compiler will jump into m3 method, right? So m3 method is now going to call whom, sir? M2 method. Nice. So M2 is the controller is going to jump into M2 method. M2 is going to do what, sir? It is going to call M1 method. So it is going into M1 method. And here you are doing what, sir? You have 10 and 2 in A and B. So 10 by 2 is going to be 5 for you. Okay. So you will get this output for yourself. You will see 5. And then what exactly happens after that? It called every property properly. Now from main method it went here, from here it went to M2, M2 to M1, and executed M1 logic here. After the logic, whenever the logic is done, it simply comes back to M2 method, wherever it was called from. Okay, so M1 is called at this statement. So now the control jump to here, and after execution all the lines of this method, the controller will come back to the same line where it came from. Okay, and now it is going to continue the statements that we have here. But do we have any statements here? We do not have any statements. So the controller is again going to jump back to M3 method. Okay, M3 method again it's the same thing. This statement is executed already. So are there any statements below this? No, we do not have those statements. So the controller again jumps back here. And do we have any statements again after M3 calling? No. So it will go back to where it was called from. The compiler went back to the JVM. From JVM it came there and it went back to JVM. Now this is an example of, you can call this as graceful termination. Meaning, you can call this as graceful, or normal termination is also a terminology that you can use. Okay, what exactly happened here is we specifically called a program, we called our JIT compiler here, and we executed entirely. The program has been executed and it went back to its initial state, right? So whenever this happens, we call this as normal termination. The program has completed its execution successfully. We call it as normal termination. Okay, now there is a scenario where user might not have entered these two values, right? What if the user enters wrong value? What if the user enters improper value, such as 0 in the denominator? There will be a problem in this entire scenario, right? So what might be that problem? Let's see that example in a new page. Okay, so I will create that same example program, but in a very fast manner. Give me 1 minute of time. Okay. I have added two specific lines in this method. Okay, I've added M1 started and M1 ended. So whenever the control comes here, it will execute this stating that M1 has started, and whenever the control is going out of this method, it will execute this statement and then go out. So we will understand that properly where what went wrong and where, right? So that is the reason why I'm adding these two details here. Okay, so I'll do the same thing for all the methods. Let me copy this. Copy and paste. So now this is not going to be an M2 method. Instead, okay, this is not going to be M1 method. I'm going to create this as M2 without any parameters. So it will say M2 started, M2 ended, but in the place of SOP, I'm going to call M1 off, 10 comma 0 this time. This is the only case where the exception might occur, right? So that is why I'm calling it in that way. And now let's call void m3 of, where I say SOP m3 started, SOP, sorry, m2 of SOP m3 ended. Now from main method, we'll call this m3 method public static void main of string of arguments. Let's create an object and then call obj dot m3 off. And we'll also say, uh, we will also have to say this statement, right? Sorry. SOP main started, SOP main ended. Okay. So let's consider this is our entire program. This is the same program as before, but this time with a different scenario. What I'm simply doing is I am removing this here and pasting it here. So continuation of this is here so that I can zoom it a little bit in for you all to see it in a more better way. Okay. So now if you all focus on this, again, what are we going to do? We are going to still run the application. If I have saved this as Java C A dot Java, I'm going to compile it that like this, and this is going to give me a bytecode, and I am going to run that bytecode Java A, which is indirectly calling A dot main, and our control jumps to this statement. Sorry, will come from here. This is easier. Okay. The control comes to here directly. Okay. So now after getting to this control, it will now start executing m1 main method, right? So after coming to the first line of main method, what is it going to do, sir? It is going to print main started, right? So this is a statement that we'll see. And after that, what are we doing, sir? We are creating an object. Object will be created. The memory allocation will be done for all these methods. And then when we call obj.m3, m3 is going to be invoked, right? So the controller is now going to jump from here to this method. Understand, we have not executed this main ended statement, right? We have only executed here, and the controller from here jumped to m3 method, right? So in m3 method, what have we done? We have executed m3 started. So we'll write it down here. M3 started. Very good. Nice. So now after this, what are we going to do, sir? We are going to call m2 method. So now the controller will again now jump to where, sir? Let me draw that in a better way. Okay. Now the controller from that statement jump to m2, and it is going to execute m2 started. So we will write that m2 started. Okay. So coming back to this code, it is now going to call which, sir? M1 of 10, and then it is going to call this method, and it is going to print M1 started. Okay. Now the problem arises. What exactly is going to happen, sir? When it executes this statement, SOP A by B, A has 10, B has 0. 10 by 0 means what, sir? It cannot operate that specific program, so it will simply say that it is an arithmetic exception. But how exactly does it understand this? So the JVM is now stuck, right? It is trying to calculate something, but it is not able to complete that execution. Okay, so it is not able to execute that specific statement completely. Now the JVM will identify this. JVM will recognize this specific problem, and JVM will try to understand if there is any handling that has been done here. JVM will try to search for any handling in this specific method that a user has done already. or a developer has done already. But if we have to see it at a normal perspective, we haven't saw how to handle an exception up till now. We'll see that later on. But as of now, if you see, we haven't wrote any code which is not already new. So this is we can consider that there is no exception handling that is a part of this, right? So I haven't handled any exceptions. Now JVM will understand that what the user is not handling any exceptions here, right? So what exactly happens now is there is something called as exception propagation. Okay, so what does this mean is whenever there is an exception in a specific method, okay, whenever there is an exception in specific method, if the developer or the user has not handled that exception, then the responsibility of that handling of the exception is either the methods or the method who called this method. Okay, so I'll tell that again in a simple words. If M1 is actually dealing with an exception, M1 has to handle that exception, or if not, M1 is not handling that exception, then it is M2's responsibility to handle that exception, because M2 is the method which called M1, right? If you come back to the scenario, you have called M1 here. If you have not called that method here, there might not be a scenario where you might get that exception, right? You would not have got any exception here, only if you did not call that method here. So what exactly happens is the responsibility of handling that exception will also be shared by M2 method. Okay, but that just doesn't stop there itself. Okay, what exactly happens is the responsibility of M2's method is also shared with M3 method, because M3 is a method which called M2 method first, right? Again, that doesn't stop there. What happens? M3's responsibility is again shared with main method also, because main is a method which called M3 method. So JVM, it intelligently plays something here. Okay, so it will first come and check whether an exception is handled or not here. Okay, and it says that we have not handled any exception. So what it intelligently does is it will now go back to where it was called. It hasn't executed this program yet, or this method yet, right? So sorry, it hasn't executed this statement yet, but it went out of the method to check whether the exception is handled here or not. Now it is never going to execute this statement, okay? It is now directly going to execute come back to the M2 method and check whether the exception is handled here or not. And as we can see, we haven't handled anything there. So what does JVM do here? JVM will now move back to main M2 method. Okay, so it will come back to this specific step, leaving this statement unexecuted. Okay, now here it checks if it is handled or not. As again we see it is not handled here, so again it will not execute this step and it will come back to main method. Okay, and it will check again if we have handled it here. If we have handled it here, the propagation stops here. But did we do that? We did not do that. Exception propagation still continues. Okay, so what exactly happens is it will not execute this statement and it will go back to where it came from. Where did it come from, sir? From the JVM. So this is a place where JVM resides. Okay, so a.main is actually called by JVM. Okay, so JVM takes the responsibility of handling this exception. Okay, so there is something called as default exception handler. Okay, there is something called as default exception handler, which is there in JVM by default. Okay, so what it is going to do is it is going to handle that specific exception that has arisen in this scenario. Okay, we have got that exception here, right? Sorry, We got that exception here, right? So the same arithmetic exception is now going to be handled by the default exception handler of whom, sir? Of JVM. So JVM is now going to handle it, and it is going to execute a specific method. Okay. So the name of the method is print stack trace. Okay. So this is a method that is going to be executed. But what is this method? This is a method that is present in throwable class. Okay. So this class internally has print stack trace method. Okay. It also has something called as get message method and toString method. These are the three methods that we are going to use in future. But at this point of time, print stack trace method is going to be executed. Okay. But this is a non-static method. Okay. This print stack trace method is a non-static method. And this non-static methods needs to be called only with respect to an object, right? So what is the object that is going to call? We are calling that print stack trace method from JVM, right? Does JVM have any objects already available with it? No, it doesn't have any object available with it. But what happens is, in the exception propagation, what happens is whenever there is an exception that is raised in M1 method, there is an object of that specific exception that is created. Okay. There is an object of that specific exception that is created, and that is actually present in M1 method. But whenever you do not handle that specific object in that M1 method, it is now passed to M2 method. Okay, the object is now passed to M2 method, and from M2 method it came to M3 method. Okay, and from M3 method it came to main method, and from main method it went to JVM. Okay, so the object is going to travel all the way to JVM, and JVM with respect to this object, it is going to invoke print stack trace. Okay, so whenever it does this thing, while this object being traveled from all these methods, it will remember all the tracing that or the specific methods that has been crossed here. Okay, so what it does specifically is, from here it is going here, from here it is going here, from here it is going here, and it is going to remember all these steps. Okay, and that is how this statement will be displayed. Okay, when the print stack trace method is invoked with respect to the object that we have got in the JVM, no, it will say that the exception has happened in the main thread, because that everything was happening inside the main method, right? So we only have one foreground thread initially that is considered as main thread. So it is happening in main thread. It will also provide the description of where the exception happened, including the thread description. Okay, we consider this as the thread description. Okay, so it will help us to identify in which thread does this exception occur. Okay, so main is the default name of our foreground thread, so that is something that will be displayed there. And what is the name of the exception that has happened? That exception that has occurred is arithmetic exception. So the fully qualified name of that exception is displayed here. So java.lang.arithmetic exception is a fully qualified name. We can consider this as name of exception. Okay, so this is one thing. And why did this exception occur? Okay, so what is the reason behind this exception? That is this nature here. Okay, we can call this as nature of exception, or you can also call this as a message passed by the exception. Okay, this message will be there for few exceptions, will not be there for few exceptions. It is all dependent on how you deal with that specific thing. Okay, so name of the exception, name of the thread, name of the message or nature of the message, and followed by that, this is the tracing that you will see. Okay, so where did that happen? It happened in M1 method, it happened in M2 method, it happened in M3 method, it happened in main method. We did not write that line here, but main method is also responsible for this specific thing. And everything happened in a.java file in a specific line number. This is our line number. Okay, and I want you all to execute specific program like this that we have done, and observe the exception that you get, and understand the everything that we have here specifically. Okay, so that is important for us to also understand. Okay, so that is how you will be getting that statement at the end. But whatever has happened here, whatever has happened, if you understand this properly, if you see, if you come to a conclusion here, this statement has never been executed, this statement has never been executed, this statement has never been executed, and this statement is also never been executed, right? Now, it is important for us to understand one specific thing here. Okay, whenever you have a non-return type method, the compiler should only leave that method after execution of all the lines of the code. Okay, if you have 4 lines, or if you have 3 lines, you have to execute all 3 lines and then only return from that method in order to remove this method from the method stack. Okay, so what has happened here is there will be a method stack for this. Okay, so the method stack will initially first load main method, and then M1 method, and then M2 method. Sorry, I'm writing this in reverse order. It will store M3 method, M2 method, M1 method, and after completion of M1 method, this is removed here. And after completion of M2 method, this is also removed. After completion of M3 method, this is removed. After completion of main method, this is removed. And that is how the stack becomes empty again. And whenever the stack is empty, we can call it as normal termination. But in this scenario, that is not the case. Do you agree? Because we have the stack where initially main is loaded. From main, we have loaded M3. From M3, we have loaded M2. From M2, we have loaded M1. We got an exception here. There is a line that is not been executed yet, but still we got out of this method, right? So did this method come out of call stack? The answer is no. So the method is still available in call stack, but the compiler went to the M2 method. Now, M2 method, did it completely execute everything? No, because there is a statement that is already left out here. So M2 is also still there. M3 will also be still here. M4 also will be still here. And the call stack is still loaded with methods, right? And but the execution is done, because whenever it comes out of this main method and goes to JVM, it doesn't have a reason to come back again to execute all these things. It will not come back again, because whenever you call this, you are going to get to this point and start execution, right? And when you came back to the initial start point, you will not go back to the initial to the main method until or unless you are called. Okay, if you are not going to call that method again, it is not going to come and execute, right? So because these are the steps that are remaining, I'll go back and I'll execute them and complete them and come back. It is not going to do all these things specifically. Okay, so it will simply, when it came back here, it will stay here, and these lines of the code are still pending. So all these methods will still be here, and whenever this happens, we call this as abnormal termination. Okay. Exception handling is all about avoiding abnormal terminations. If you avoid abnormal termination, you will, if you complete the execution always gracefully, then you will never have to worry about program flow of execution. Okay, so all your goal in any application development cycle is to create a program which doesn't end up abnormally. Okay, you should always make sure that you will always make sure that the program always terminates with graceful termination. Okay, so that is something that you have to always do, guys. Okay, so to do that, to avoid this abnormal termination, we are going to use something called as exception handling. Okay, how are we going to handle these exceptions? Now, that is a topic that we are going to talk tomorrow. Okay, so what have we done today? We have done of understanding what is an exception. Okay, what is an exception? what is an error, and differences between error and exception. Okay, this was our initial part to understand what exactly is an exception, what exactly is an error, and the differences between an error and an exception. This was the initial stage. And then we saw the classification of exceptions. Okay, and we also understood why we should not handle an error, why it is not meant to be handled, and why we only handle exceptions specifically. Okay, and then we have seen the hierarchy of exception API in Java. Okay, so the hierarchy of entire exception API is also something that we have seen. Okay, and followed by that, we have discussed about the graceful termination, and we have understood abnormal termination also. So now specifically, we have to understand how are we going to handle the exceptions, right? So there are few things that are left. We have to understand how to handle exceptions. Okay, and uh, keywords that help in handling. This is something that you will have to understand. And then user defined exceptions. How to create an user defined exception is something that we are also going to see at the last. Okay, so these are the pending topics that we have. We have almost covered the theoretical part of exception. We only spoke about the entire theoretical part of exceptions here. Okay, so in tomorrow's class, what are we going to cover? We are going to learn what are the ways that we can handle exceptions. If we know the exceptions, how do we handle them? If we do not know the exceptions, how do we handle them? And what are all the keywords that are included here? And how do we create our own custom defined exceptions? How do we handle our exceptions? Do we handle our custom defined exceptions or not? There are so many things that are much more interesting and important for us to learn, which we are going to do that in tomorrow's class. As of now, for today's class, this is all, guys. Okay, thank you so much, and we will meet again tomorrow.